All right, let's go on to number 10. Let's look at these equations. X plus y equals 3 and 3x plus 3y equals 9. Okay, we have some work to do with those before we can graph them. So let's take this first one and let's move it to slope-intercept form. So I'm going to shift that x. Oh, hold on, there's no x there. Let me erase it. So we're going to shift the x over to the other side. So we have y equals negative x plus 3. Okay, we're ready to go with that one. Let's just work on this one too while we're here. So I'm going to subtract 3x to shift that over to the other side. So I have 3y equals negative 3x plus 9. Now, when we divide everything by 3, we have negative 3 divided by 3 is 1, so negative x plus 3. Well, that's interesting because they're the same equations. That means that one would lay on top of the other, and they would intersect at an infinite number of points. So I'm just going to graph it once. And here's what I always do to show that one is on top of the other when you graph it. I just put a couple sets of arrows, and I'll show you what I mean. So here's my line. If you would actually graph them twice, one would lay exactly on top of the other. Your solution to this is infinite solutions, or infinitely many solutions. That means that no matter what points or what coordinates you plug in there, it's always going to work. So your answer to that is infinitely many solutions. All right, number 11. In the table below, draw an example of a graph that represents the different solving outcomes of a system. Okay, so one solution, I'm just going to sketch it in there, is going to look like this. Okay? So one solution, these always have different slopes. Different slopes. No solution, you're always going to have lines that never touch like this, parallel lines. So they're going to have the same slopes. If you're looking at the equations, the same slopes. But different y-intercepts, different b's. Infinitely many solutions, remember we just graphed that, is when you're graphing the same line. So you're going to have the same slope and the same y-intercepts. So you can kind of tell without graphing just by looking at the equations what you're going to have. Okay? So ironically, the next part is telling how many solutions you have, not what the solution is, but how many you have without graphing. So your answers here are going to be one solution, no solution, or infinitely many solutions. Okay? So they have to be in slope-intercept form so you can look at the slope and the y-intercept. So if we look here, the slopes are different. So we already know we have one solution. One solution. Letter B. If you look at the slopes, here they are. This one's not in slope-intercept form, so I'm going to subtract that 2/3 x from both sides. So now I have 1 equals negative 2/3 x plus 1. They have the same slope, but different y-intercepts, so this is going to be no solution. C. One of those you got in slope-intercept form, but this one you're going to have to subtract 2x from each side. So I have y equals negative 2x plus 8. These are the two that I'm looking at. The slopes are different because one is negative and one is positive. That always gives us one solution if the slopes are different. D, we got some work to do. We're going to have to subtract x from both sides. So I have y equals negative x plus 5. That's one of them. And here, I'm adding 2x to each side. We got to get this in slope-intercept form. I have y equals negative 2y equals negative 2x plus 10. I'm going to divide everything by negative 2. So I have y this is a positive, sorry, y equals negative x this is minus, sorry, I copied this wrong. So this is plus 5. So I have y equals negative x plus 5 and y equals negative plus 5, same thing, same equation. So this is infinite solutions. Same slope, same y-intercept. Sorry about that. Okay. E. I'm going to subtract 3x from both sides. So I have 2y equals negative 3x plus 5. I'm going to divide by 2. Y equals negative 3 halves x plus 5 halves. Pretty fractiony. Here, I'm going to subtract 3x, so we're on the same track. So I have 2y equals negative 3x plus 6. I'm going to divide by 2. So I have y equals negative 3 halves x plus 3. So same slopes, but different y-intercepts. So this one will be no solution. All right, F, we have one already in a slope-intercept form. We got to shift this other one around. I'm going to subtract 4x from both sides. So I have negative 2y equals negative 4x minus 10. I'm going to be more careful with the signs. So y equals positive 2x plus 5. And if you look at that, it's the same equation. Same slope, same y-intercept. So this is infinitely many solutions. Infinite. No matter what you plugged in there, it would work for both of them. All right, we have one more here. One equation in a system of linear equations is 6x plus 4y equals negative 12. So we have to write a second equation to make that a system that'll have one solution, no solutions, and infinitely many solutions. So the first thing we're going to do is move that around to slope-intercept form. So I'm going to subtract 6x from both sides. So I have 4y equals negative 6x minus 12. And I'm going to divide by 4. So now I have y equals negative 6/4 minus 3. I'm going to reduce that. So here's my ultimate equation. Y equals negative 3 halves x minus 3. One solution, all I have to do is have something with a different slope. So if I put y equals 2x plus 9, just need a different slope. Write a second equation for the system so that it has no solution. So I would use the same slope, but a different y-intercept. You could have lots of different answers here. And infinitely many solutions, you can only have one. So same slope, same y-intercept. Okay, that's all we have for now.